Okay, welcome to This Week in SU2. We took a week off. I know you missed us, but we're back. Today we have another extra special surprise. We've got an extra person here in the panel. So this week we have Santiago, Andrew, David, Tom, Francisco, Heather, and we have Aniket in the control room. So okay, so we're going to get to our normal program here. So first we're going to talk about an issue or a recent development, and then we're going to go into questions. And the first thing we'd like to do is talk a little bit about our new developer page and some interesting challenges we posted on the developer page. So the first thing I want to do real quick before we discuss it is pop over to the screen and show it very quickly, and then we want to kind of discuss it. So let me hop over and do that. So if you go to our homepage now, you'll see that we have this new tab up top for develop. So if you click on that, we showed this a couple weeks ago, the initial draft of it, and we're still working on it. In fact, one thing to note is we're still adding people and teams around the world that are developing the code, and we'll come back to that in a little bit. But if you scroll down, one thing we've done is at the bottom, we've posted some ideas for how we want folks in the community to get involved and things that they can start working on in order to improve the code or add new features. And so we kind of wanted to have a roundtable discussion about some of these features and why we think they're important or what we think could be useful for folks in the open source for getting involved. So the first one is a GUI, and with that I guess we can flip back off the screen. But the first thing we want to talk about is the merits of having a GUI in the code. And this one comes up all the time. In fact, I was just at the Pointwise user group meeting last week, and somebody from TechPlot, one of the first things they asked me was, to get a GUI, are you ever going to have a GUI?
Yeah, don't we really need a GUI or no?
Why did he ask that? Do you know?
Yeah, just for usability. He has a student that is working with the code, and for getting started, it is nice to have a GUI to make it easier to use. But is that important?
Yeah, for getting started, yeah, if we want to create something like Fluent or CFX, yeah, we can create some kind of GUI. But I'm not sure if it is useful for the kind of clients that we have, universities or big companies that they have their own cluster and they don't run this kind of problem in a GUI.
So from my point of view, I guess having a GUI to run the whole code and be able to visualize it, I don't think it will be too useful for the same reasons you mentioned, Francisco. Also because you want to be able to interact quickly, and a command line uses very little memory. It's easier to just see what's going on. But when it comes to creating the config file, I personally think having a GUI just to create the config file every time will be useful. It will eliminate some of the common mistakes when you forget to put an option or kind of get the code updated and forget to update your config file. It'll just make life easier to go through there rather than to go to a text file editor and delete some parts.
I don't know, as a power user, I'm going to say I don't want a GUI. Get it out of my
there are some private companies who are working in this cloud computing world, and they have created, I think they have created a GUI for YouTube, maybe?
Yeah, it's kind of under the hood, along with some other tools.
A
few others.
Maybe it's useful to have a GUI, but we don't go in that direction. So
I think this is another one of those examples of something that everybody would like to have, but we don't necessarily have the resources to work on our research and what we do. But this is one of those things that if folks out there really want a GUI, if somebody really wants to invest the time to implement it, we obviously are happy to talk to and support that. But maybe that's just me saying I'm not going to work on it. Maybe one of you guys wants to work on a GUI.
I agree with you. Like in the academic side, for what we are here to try to push forward CFD, not really create GUIs, and for some of the things that we do, I think what we have is sufficient.
Yeah.
But it will be nice to see a GUI. So somebody out there, if they want to make it more user-friendly or they have some free time and want to create a GUI and experience, create a GUI for a big CFD platform, this will be a great project.
And remember, if you want easy to use CFD code, we have SU2 EDU that we are going to release a new intermediate release very soon. And that's very easy to use and really do not require any kind of GUI because it's just 10 options of 5 different options that you can specify very easily. So,
and that actually reminds me, one other thing with GUIs is portability, which to install the code easily on a lot of platforms. So you're just using standard C. This is one of the things we try to avoid. In fact, we'll probably talk about it a little bit later.
Do you know something I would like to see?
What's that?
I would like to see SU2 in the Apple Store.
We've talked about this. Yeah.
So-
In fact, Anakin, you even at one point you made an executable with a nice little icon and everything for.
Isn't that what we're still using?
For Mac.
Yeah, we are using that for
Yeah.
EU version. We need to update that for. Probably we need to understand what that's the step that we need to follow to have that in the Apple Store.
Okay.
Huh,
Yeah.
that'd be kind of cool.
Would it be
What's-
a source code download from the Apple Store, or would it just be a
Yeah,
binary
that's the
download?
idea. A source code download from the Apple Store and able to run. Maybe we need a small GUI for the config file, but we need to explore what we need. What are the specifications of the code to do that?
So, yeah, one thing I wanted to, we did put some thought into the config file a few times, like in organizing things in sections, and I think compared to other codes I've used, it's much to work with this config file. So part of it is I think we're familiar with it, but it is quite good. So and I'm sure you guys are using it.
Yeah, I think one of the nicer things of SU2 is that has been developed by people that use it a lot. So we are not software developers, so we know what to do to make it.
We end up being software developers.
We don't want to be software developers. That's the reason we don't want to write the GUI. But okay, let's move on.
Yeah. Okay. Let's talk about a couple other topics in the next few minutes before we go to questions. So another one, this one will probably be quicker, but there's another whole piece on CGNS files and kind of expanding the capability that we have in the code. So right now we have CGNS file in, and we can write CGNS solution files, but they aren't actually linked. So normally what you would do is read in the CGNS file, the mesh, run the calculation, and then store the solution in the same CGNS file. Okay, so there are a lot of features and things you can do with CGNS that we're just not doing yet. So one thought is if there's a CGNS expert out there that really wants to have these features, that they can go ahead and implement that. And I think the biggest piece is, we talk about it quite a bit as a group, maybe not necessarily CGNS, but going to binary formats at some point, or at least having that as an option and being able to do parallel I/O more easily. So we're talking about these things, we're going in that direction, but I'm not sure if anybody wants to add anything about file I/O or thoughts about that.
I think binaries is something that is critical, and CGNS would be great, nice, but binaries is
The place we can probably start there is just having a native binary format of our own. The restart file and our mesh file, we could just do binary. So I think you'll probably see us going in that direction. The really nice thing about the the ASCII mesh files we use at the moment is, for getting up and running, and you can just open the mesh file and play around with it, change boundaries, whatever. But when you start going to these large cases, it becomes a problem. I mean, if you're running 100 million cell mesh, these files are gigs and gigs, so it's not it's not great. But
yeah, it's not great.
Anyway.
It's a problem. You can still do it. I have done that without opening. For example, if you want to add the FFD box, you can always use cat and
just put it at the end.
You don't need to open this huge file, but yeah, it's something that we need to.
Storage-wise, it will also be really useful to have the binaries. I know some clusters give you a maximum amount of storage that you can have on their, kind of like on the shared meshes that are really, really big, eat up a big chunk of your memory, limiting the space that you have to run a couple cases at the time. So you have to get clever on when to put them in, when to move them out, and just kind of take away all the files. So
We are hitting some problem with that because, particularly with the optimization.
yeah, you write a lot of data during the optimization. Yeah, this is one of those typical things where we are balancing usability and code friendliness with high performance. This is our typical trade-off that we make. I mean, this is like every day for us.
Yeah, and I
This
think
is trying to
most of the
decide.
improvement that we are going to do in SU2 during the next year are going to be related with this kind of problem. We are starting running very large cases, and we need to solve this problem.
Okay, let's talk about one more topic real quick before we jump into questions. The last thing on that page that we wanted to mention is documentation. So I think we're at a point where we spent a lot of time building up a set of documentation and a bunch of tutorials, about 10 or so, and we kind of feel like there are a lot of folks out there using the code, and it's a great way for people to get started. Help you learn the code. A good way to do that is just to write a tutorial or write a little bit of documentation or even record a little screencast of you doing something in the code. So one thing we wanted to recommend to people out there is is start creating your own documentation, or anybody out there
how
can
I
help.
can create mine.
And so how can you create it? I don't know. So what do you guys think? What's a good way to get more folks involved in creating documentation?
I think one of the ideas that we've been mentioning a lot through this podcasts or video casts is to be able to create your own short tutorials on how to run a particular case. And I think that will be a good way to get started with documentation, because you'll share what you are doing, you'll share how to do it, and the rest of the community can take advantage of that as well.
Yeah, I mean, I would say that if you're trying to run a case based after looking at the initial tutorials and there's something that's unclear to you, and then through questions or working with the code, you figure out, oh, okay, I understand this now. We'll create a video cast of explaining what concept, why it was difficult, and then how you solved it, so that people in the future can avoid that problem.
Yeah, and actually, Aniket, if I can jump to the screen real quick, I think one thing we want to point out to folks, we are starting to put all the documentation on GitHub. So if I go to GitHub, go to SU2, if you go to our SU2 page, what you'll see on the right is a wiki. So what we started to do is copy over all of our documentation to the wiki on GitHub. And this is something that, folks, we can give permission to people to log in and add more documentation. We're still in the process of copying stuff, so you notice these red ones don't exist yet. But for instance, here's the page for the mesh files, right? So we explain our mesh file formats. So one thing we can do is have on GitHub, adding new documentation, and we can also have people submit new test cases through GitHub, which is another repository that we have available. So people can submit pull requests with their own test cases, and we can check them out and try to test them ourselves and add them.
Well, then there's also the issue of, well, we're suggesting these as potential options that people can explore because we've heard about them in the past. If someone wants another capability in SU2, we also just recommend you add it to the issue tracker, and it's your responsibility to kind of go through the issues up to the point when you're submitting one, and making sure that what you want to add to the code isn't already being added by another user group. But I think that's a good way to get people involved also.
Yeah. And I guess if you add a new capability, as a lot of the contributors have been doing, it would be good to have some sort of documentation of how you would run like a sample test case of what you added.
Maybe also explain like what are the limitations of that new capability that you're creating, what can it be used for, and the little example that you say either on the video format or maybe in the same format that we have the current tutorials, that is just the mesh, the config file, and then instructions on what has changed, what needs to be added, and how to make it work.
I think the limitation is a good idea, because people will always like, you implemented something and people will try to do something completely different. And it doesn't work. I think putting ahead of time like what the intended use is and like what it's validated for will be good.
Yeah.
Okay. Any other thoughts before we go into questions?
Yeah, we are gonna try to acknowledge everybody who contribute to the code. So please, if you want to contribute, let us know, and we will acknowledge you. And
yeah, drop us a line, put something on GitHub. We'd like to have your info if you're developing the code. We'll list you in the list of developers, and yeah, please just let us know if you're working on something or you want to start working on something. So we'd love to have your support. Okay, so question time. Questions ready? So again, we're going to do what we normally do. We've got, let's see, 4 questions today. So I'll go ahead and read the question, and then we'll kind of discuss what we think the best strategy is to give you a good answer. So, all right, let's start with this first one on multigrid. This is a very good question from Thomas about kind of multigrid in general and how to diagnose multigrid stability issues. So the question reads, I'm just going to read parts and we can walk through it together, but they would like to develop a public model that demonstrates the issues, how you diagnose issues with multigrid, and facilitates making a more robust multigrid solver. So this is a very hot topic, especially for us right now, especially for some of the high performance cases, some of the stuff we're working on in the code. We're working on this very actively, so it's a great question. So they've been having some problems with the most recent version, and they want to be solving flow around business jet and transonic flow. So they'd like to use multigrid to accelerate the convergence, which is great, but we're running into stability issues with the multigrid and not sure at this point how to diagnose the problems. So details about what their setup is like, but maybe we can just talk a little bit in general about multigrid and stability issues and maybe what we're working on or what you're working on in the multigrid solver in order to kind of alleviate that problem a little bit. So.
Yeah, so as far as I see, you are using the latest version. I think that we have improved quite a bit the multigrid during the last 2 months, maybe. But there's still some issues to fix. Multigrid is always a source of problem, but it is worth it to use it when you are not able to increase the CFL number. So in my opinion, multigrid is great. Obviously, you have an explicit scheme, so if you have memory issues, you don't have enough memory in your computer, so you want to use an explicit scheme, then you need to combine that with multigrid just to obtain the performance and to converge your program. But if you don't have any kind of memory issues, you can always run the code in implicit mode. And if your grid has the right quality, then you can increase the CFL number up to 10 or 100. In that situation, it's not still clear for me that the multigrid is going to give you some real improvement. The multigrid that we have implemented is based on a local decomposition, so at the end there is a limit in the number of agglomeration levels that you can create for a particular partition.
I wanted to know that they say that the number of mesh partitions affects it. Yeah, so what happens is Metis is used to decompose the mesh, and then within each domain that's passed around each processor, they do a local agglomeration. So if you start with a smaller chunk of cells, you can only agglomerate so many times. So you can only build so many coarse representations out of a smaller chunk. So that's why your solution and what changes depending on how many partitions you have. So this is one thing we're actually starting to think about on a little bit, is how to make a more robust agglomeration routine in parallel and how to go about that. So it's something we've been playing with.
I'm going to use the computer for a while, so please.
Here we are. So what I'm gonna show you is what I typically do when I have problem with the multigrid before disconnecting. So if you go to the multigrid part, multigrid. This is resolver, face. Here we are. Close. Limit multigrid. So first of all, you specify the number of levels. If you have a problem with the number of levels of multigrid that you have, you can always reduce that number. But what I have found critical to make it converge is to reduce this and this. So the multigrid dump restriction or the multigrid dump prolongation. So now we are using 0.75. You can go to 0.5. Below 0.5, it doesn't make too much. And another thing that sometimes helps is to just one pre-smoothing this. So I think this is a very conservative setting for the multigrid. So you can try this kind of conservative setting, and if this doesn't work and you have a high CFL number, do not worry and just use the implicit backward Euler without multigrid, and you will have a quite good performance. That's everything I want to say about.
Great. Yeah, I mean, like Francisco was saying, we are working on this part of the code very, very actively because we suspect that as we start going to these really massively parallel type of applications, these large cases, we're going to need a very robust multigrid. So this is something we're working on hard. You'll probably see a lot over the next.
Please, we have improved a lot. So we have worked on this.
Yeah,
I think much better than
from 1.0 to 3.2.3. You put in a ton of work. I mean, 3.2.3 is very. There are a lot of nice features.
There is something important here, maybe this paragraph, because I don't see any improvement in performance when substituted to
more than one node.
Each node.
Each node has 32 CPUs and 64 gigs.
I think it's
I guess I would maybe if you could give us a little more info, because improvement in performance, are you thinking in wall clock time, or are you thinking in to convergence, or I guess it's a little unclear to me.
Yeah, we run in a lot of nodes. We have run in thousands of cores and different nodes.
Yeah.
So We have not.
We
seen
expect,
that.
one good rule of thumb here is we expect that as you run on more cores, we expect linear scalability up to however many cores you can get, as long as you keep about 5,000 grid points per core. So that's our rule of thumb that we're using right now. We're trying to push that down as much as we can. We're working on that. But if you keep 5,000 grid nodes per core, you should scale basically linearly. So you could just be, the mesh maybe is just too small, and you're decomposing it too much, and you've already kind of leveled out. You're not scaling anymore. So,
So
but give that a
one
look.
thing to keep in mind there is the frequency that you write your solution files. If your solution files are written too frequent, it will take longer. And at some point, if you just write them every iteration, it doesn't matter how many cores you use, the computation will take no time, and then writing the solution will take a while. So you have to also delay a little bit your solution writing. It's one of the parameters in the config file.
Especially for unsteady.
Especially for
Or queue
unsteady.
run, yeah. So be careful with your I/O, because as everybody knows, I/O can kind of ruin your performance. So.
Is it also true that it might be dependent on things like cluster architecture, where like if there's a lot of communication overhead for going to multiple nodes?
Yeah, maybe you don't have a nice fancy InfiniBand network or something, and
Yeah,
you're on Ethernet,
that's
and communications could be killing you. So yeah, good call. Good call. Okay, this next one should be very quick. I'm going to take this one. We have a question from Frederic. They say, greetings, there have been a few references to the development of wall functions in SU2. There are a few other posts that mention it. Are they currently implemented? Are they automatically enabled? Et cetera, et cetera. This one's on my plate. That's my branch, maybe you've seen in the repository, called feature wall functions. It's about 90 complete, and I've been dragging my feet a little bit on it. So I have the initial work there. It's not complete. It will not work. We're still in V&V mode, but if you'd like to, or even play around with it a little bit, you can just pull down that branch and take a look at what I've done. I've made, I don't know, a handful of commits, maybe 5 to 10 commits where I've put in different pieces. So, and really what you'll see is some modifications to the boundary conditions in both the mean flow solver and the turbulence model. I'm starting with the SA model, but it's easily extendable to the SST model. So you'll see that I've added a couple routines called compute wall functions that are down near the no-slip wall conditions. And essentially the wall functions are just a way to relieve your grid requirements a little bit. So if you know that you have a nice smooth attached flow, you can assume some things about the boundary layer, what it's like, some of the quantities in the boundary layer, and you can sort of impose some other relationships that allow you to have less high stretching near the walls and better convergence, et cetera, et cetera. So that's there. It's being worked on. If you'd like to pull it down and look at it, please do.
Do you need help?
If you'd like to hey, we'd be all ears. If somebody wants to work on it out there, please let us know. Let me know. I'm happy to show you what I've done, and yeah, if you'd like to finish it off or test it, that'd be great. So let us know. Let us know. Okay, so let's move on to the next one. We have a question that is about LAPACK. So the question is from Shaneth, and it is, I want to use functions of LAPACK in SU2. Can you give me some guidelines on how to do so? So Heather, do you want to talk a little bit about this one?
Okay, so I guess the first thing to talk about is that the linear algebra routines are implemented in SU2 rather than using an external library, which was a decision made for to reduce dependencies and make it easier to install. And I guess we can show you where in the code the linear solvers are.
I think that would be very useful.
Yeah, I think to follow on your point, one of the things we've tried to do is avoid the overhead of having to install certain packages, things like PETC or whatever. We know that these are very high performance, great libraries, but we know it causes issues sometimes for folks to get them installed and get them set up. So it's just, as far as usability in an open source code goes, we try to have as many in-house solutions as we can. So
yeah, I guess I probably want to zoom in on this. Yeah, well, so the place in the code where this is in common source linear solver structure.cpp, which I have pulled up here. All right. So you can look in here for the various functions that are called and other routines. We have
And then are you looking for a particular?
some for GMRes, I guess. Okay. So in these functions are where there's some opportunities to, if you wanted to use a LAPACK library, this is the sort of place where modifications could be made and see if that increases performance.
Yeah, one thing that we've done in the past is talked a little bit about using other libraries like Intel's math kernel library. They have routines that do sparse matrix vector multiplies. We have our own sparse matrix vector multiply, but you could very easily plug in your own different library that does it in here. And also, you know, there are a few other opportunities like that. I mean, most of the Krylov methods, the sparse matrix vector multiply is kind of doing the heavy lifting. So
yeah,
we
and
talked
it
about
should
that.
be
Or
easy because,
preconditioners.
yeah, the kind of sparse matrix storage that we have is probably
Yeah.
the most standard one.
The
so
block.
Block
CSR,
CSR,
yeah, I always
yeah.
forget if it's CSR or VSR. It's
But
one of the standard,
the standard one,
storage
so,
formats that we use, yeah.
In principle, the coupling is very straightforward.
Yeah,
Yeah.
one thing I want to add, inside this routine solve, so the linear solver, like pretty much any, well, it'll be called by the main solve, we call in lots of places of the code, so that's, I don't know what kind of problem you're trying to solve, but it'll be called in many places, and then once it's called, it will go to the linear solve, and then and then like there's different options here. So we have the two Krylov solvers, VCO stuff, and FMGMRes, and a restart FMGMRes. But also in here, like you can make a case we'll call it LAPACK, and then it will call it particular GMRes or something like that. Yeah, but again, I guess the reason why we're doing we use our own is just to reduce the number of dependencies. And it's a little bit clearer to see what's going on as well. It's all there.
Yeah, we are working on linear solvers too. So
Yeah.
if you want
like
to
research
it's a
opportunity.
yeah, it's a very interesting research opportunity for us. So.
And preconditioners in particular, that's another hot area right now for linear algebra research. So, okay, we've got one more question, so let's jump into it. This one actually ties back to multigrid we were just talking about a minute ago. So the question is from Jan. They're having a problem running SU2 in Yosemite. They've installed it on their Mac machine, downloaded the binaries, but the problem is when they run the installed version, they get the following error. And since you guys can't see it, what's happening is at the command line, they're trying to call the parallel computation script. And it's throwing back an error that says max children, invalid option name, and max dimension, invalid option name. So they want to know how we can resolve this problem.
Sure. First off, let's talk a little bit about the difference between having the binaries and compiling your own code when you're trying to do work in parallel. The binaries that we provide are compiled to do serial work, so they are not capable to be able to run in parallel. So what's going to happen if you manage to run them with the MPI run is that it's just going to have many serial cases running at the same time. So you're not parallelizing your case, you're just running multiple cases. The solution for this is simple, is instead of using the binaries, you take the code and you compile it yourself using the MPI and the Mathis capabilities or features.
And remember that we have Xtool, what's the name of this? So the external and all the files to generate the project using Xcode.
Oh, the Xcode project files.
Yeah, we have those. So it's easy to compile.
Yeah, there's the Xcode project files in there. So if you use Xcode, you can open the project that is the SU2 code, and you can just quickly compile from there, and it will actually give you the chance to be able to compile it using MPI and using Mathis. Different way to do that is just from the command line. If you download it from GitHub, you can just do the make configure with MPI rather than with just the normal C++ compiler. And that will also compile Mathis automatically. I think now that is built in, so you just have to do the compile with MPI. And after that, you will be able to either run it with the Python wrapper, like the one that you're showing here, the parallel computation, or you can also go module by doing just SU2 PRT to partition it, and then SU2 CFD to be able to run the case.
Yeah, for the other half of the question where you're talking about max children, invalid option name, and the same with the max dimension, I believe with the newest version that we have on GitHub, these are names that you don't need anymore in the config file, so you can actually just delete those because we just now do that under the hood. So if you just get, anytime you see those invalid option name, it means it's just a name that the config file doesn't accept. So you can get rid of it, and then that should at least eliminate those errors.
Yeah, a few versions ago we put in a stricter config file parser. So now don't be too scared when you see those, just toss them out. It just means that it's supposed to help you if there are redundant options or things that are in there that don't exist anymore.
It's good practice to try to go and download the new config file every time you download a new version of the code, just in case there's some major changes like this in the multi-grid that will create a little bit of conflict. But if nothing else, like Tom mentioned, you can go in, find where this features or where these names are being called in your config file, and you can either comment them out if you're not sure that they need to be deleted, just straight up take them off your config file, and then it will run just fine.
Yeah, most options don't change names. Well, what happens is, like with these, they just get defaulted in the code. So we don't need them, but it's we try not to change name of options. But if you get an invalid option name, just go look and maybe the name changed a bit or something.
Yeah, and if you want to look in the code, all the config options you can find in config structure.cpp. You'll see a list of all the near the top of the file, all the things that are currently active. So you can always go check there. And the config template.cfg that's in the root directory is, we try to use that as our master list and keep that up to date and leave nice comments and everything. So you can always check there.
Okay.
Any other thoughts
No?
on that one? No? All right, then let's shut it down for the week, and we'll come back, I guess, next week or the week after, and we'll do it again. So, all right, thanks for joining us, guys.
Thank you very much.
Okay.